Good evening, everyone. In the previous session, we saw a few concepts relating to NLTK. So, we have covered a lot, but please don't be overwhelmed. This is nothing. You'll be able to grasp it like as you practice more and more. So, yeah. So, in the previous session, let us do a brief recap of what we covered in the previous class, and then we'll go on to some of the concepts in today's class. And yeah. We'll keep this session a little short so that you get some time, to uh, ask your queries and also revise more. So, in the previous session, sorry, in the previous session, we saw an application of NLTK library for a natural language processing task called stylometry analysis, in which the task was to identify uh, if a text belongs to a certain person or not. And for that, we extracted certain features out of the text using the analytic library. And we just took a sample text and then we tokenized it into words and sentences. Saw the frequency distribution of the words, like we saw what are the most common words that are there in this particular text, and at the sentence level, we were trying to see the average sentence length in terms of the number of words per sentence, and so on. So these are some of the features that you can extract from the text. You can extract even more features like how many verbs are there, how many nouns are there, and so on. So it all depends on the kind of features you would like to, after observing the data, you would like to extract. So that was all about the NLTK library for stylometry analysis. And then we moved on to discussing Network X library. And in that, we discussed a few basic concepts relating to graph theory in computer science. And we discussed different types of graphs that are there and how they are represented. And then we moved on to seeing the usage of Network X library and how we can create graphs in Python using NetworkX, how you can add nodes and edges in different ways. And then also there were like different types of graph that we saw, like connected, disconnected in theory as well as in NetworkX library. So that was all about the NetworkX part of it. And then we also saw some applications that, uh, in which graph theory is applied in computer science, like in the social media analysis and so on. So this was all about the NetworkX, and then we saw strings in Python, which we'll be continuing today as well. So we'll do a brief recap of strings, and then we'll move on to NumPy library, and then uh, we'll see two problems, which I'll be discussing towards the end of the some two programming problems relating to the concepts that were covered in the class, and then we'll end the session. So are there any queries so far? Sorry. Okay. So before we begin, there were two good questions from Mastan, and one of them was like, does the blank space before word shall be indexed? So yes, that is also indexed because it is also a character. Like for example, let me show you over here. So as anyway, we are discussing strings today. So let me see uh, some sample string. Space A, B, C, D. And if I print the length of sample string, so it will be 5 because this space character over here is also a character. And we'll discuss it later in this tutorial as well, like how we can, identify if a given string has only the white spaces or not. So this blank space is also known as white space. Uh, there are different terms associated with it. So they do mean the same thing. Okay. So let us also try indexing, printing something. So sample string of, let's say, 1, if I print, that will give me A. And if I print sample string of 0, that will give me this white space over here. Can you see this? It is in quotation mark and there is a space over here. So that is also being taken into account as a character. So I hope that clarifies your first query, Mastan. And second query was when all time, if we are giving something as input, what will be the data type of the variable? So that all depends on the way in which you are giving input. For example, uh, let's say I write a equal to 2. So in this case, a is by default integer. Uh, Python is a dynamically typed language. So there are two types of languages. One is statically typed or static typed. I don't remember exact terminology for that. And then there is another set of programming languages which are dynamically typed. So, sorry, in like static typed programming languages like C, C++, you'll have to explicitly mention the data type of a variable. For example, in C, you'll have to write something like int a equal to 2 and so on. So, you know, like you cannot change the data type of this variable unless and until you redeclare it with some other data type later. However, in Python, you can assign a variable with any value and it will take that, it will become a variable of that particular data type. For example, if you write a equal to 2, it will be an integer. If you write a equal to 2.0 or 2.3, it will be a float. And if you write a equal to, size, so it will be a string and so on. A equal to 2 will be a boolean and so on. Um, However, you can also change the type of uh, data type of a variable. Like for example, if you write a equal to 2 and let me print the type of a, and we discussed this multiple times. So I can also write a equal to, float of a and print, sorry, type of a. So let me print this. So you can see that in the first instance, a is belonging to, let me also print the value of a, print a and print a over here. So you can see that in the first instance, a is printed as 2, and in the second instance, a is printed as 2.0 because I'm converting it explicitly to float. Similarly, if I have this variable b equal to 2.3 and let me print b, and if I do b equal to int of b, means I'm converting it to integer, and now if I try to print b and print type of b, sorry, so you can see that b is 2.3. However, when I'm converting into float, so there is a loss of information over here. So this decimal point, the numbers after this decimal points are getting truncated. So yeah, you'll have to be very careful in Python, like while doing this type conversion from one type to another type. So if you are converting from int to float, there is no loss of information. But however, like if you are converting from float to int, so there is definitely a loss of information if there's something is there after the decimal point. Okay. And then coming to user input. So if you are taking like input like from the user, so always the type of the data variable will be string. So let me just do this. Let me just call it C. And even if I give 1, 2, 3 over here, you can see that the type of this particular variable is always a string. So you'll have to explicitly convert it to an integer. So or float, depending on what kind of, uh, sorry, variable it is, variable you want or input you are taking. So yeah, here you can see that I've just explicitly converted this input to int, and then I'm just printing the type of this int variable c, and it's integer in nature. Okay, so I hope this clarifies your queries. Is it clear so far? Okay, great. Sorry. So in today's session, we'll look into string library and then some string mo- functionalities, and we'll move on to discussing NumPy library, some applications again. We have discussed this, but just a recap. And we might have missed on some of the things in NumPy library, so we'll discuss that as well. And then we'll see two problems, which I'll come to that later. So let us discuss quickly strings. And there are certain things which we did not discuss last time, but yeah, we'll discuss it today. So string in general, like string is a data type in Python that we have seen already, and there are certain functions that are available in for this string data type. For example, like for in list, for li sorry, for list data type, like let's say we have list L equal to 1, 2, 3, 4. So we had these functions called list dot sort and then list dot append and so on. So it is all defined in the list class. Okay, what is class? We'll not discuss. We will not go into the details of that. Like that, that comes under the realm of object-oriented programming. But there are certain functions which are defined for list data type. Okay, similarly for set and dictionaries and so on. So there are certain functions, inbuilt functions that are defined for all these data types. Similarly, for the string data type, okay, forget about this import string. This is something else. So string in general is also a data type, and then you can apply certain. It has certain inbuilt functionalities which you can use to do certain operations on that string. Okay, so yeah, let me just uncomment this. So let's say I have this sample string over here. Yeah. So as we discussed in the previous session, there are different operations that you can perform on the string. So first is converting it to uppercase. So sample string dot upper. Uh, so upper is a function, and there is this dot. There is this dot operator. Sorry. So dot is also an operator in Python, like plus, minus, and so on. So sample string dot, and then you're calling this function. Okay. So this will apply uh, uh, like like this will make all the characters in this particular string in uppercase, and then store it in a memory, and then pass it on to the another variable. Okay, assign it to the other variable. However, you will have to keep it in mind that the sample string is not being changed. Sample string dot upper will give you only the view of the upper case of the string. For example, let me just take this over here. Okay, and let me also print sample string here. So you can see that the uppercase string over here, which is being assigned the sample string dot upper, is getting changed to all caps. However, the original string remains as it is. And we have seen this in the previous session as well, that strings are immutable in nature. So you cannot, modify strings as it is, means in place, but you can, modify a copy in memory and then assign it to some variable. So this internally creates a copy of the string uh, with certain operation and then stores it in another variable. Okay, so that was all about this uppercase, and you'll have to keep it in mind that strings are whatever operations you're performing, it is not being performed on the string. Means like the string is not getting updated. Original string will remain as it is. Similarly, sample string dot lower will convert everything in this string to lowercase. So let me quickly run this as well over here. So you can see that all this capital H, capital W, and everything got changed to lowercase. So why do we need this, like in first place? This is needed when you want to compare two different strings, okay? Like character by character. So like if I have a string like say hello, my name is Saish, and hello, if I just write my name is Saish. So if you do equality over here, check. Let me just comment this out. Assign it to a string called A, like variable A. This is variable B, and let me just print A equal to B. So you'll see that it is false, even though the characters are the same, but the cases are different. Like here, M is in capital case, N is in capital case, and so on. However, if you do A dot lower and B dot lower, so in this case, you'll see that this is true because everything is being converted to a lower case, and then you can compare the two sentences or whatever strings you have, you know. So, yeah, if you want to compare two long strings or something, you can use this A dot lower and B dot lower. We'll see some examples later as well. So, that was all about uppercase and lowercase. And then we have something called as title case. So what is a title case? Like it is nothing but like converting every first digit of a word of words in a given string to capital. For example, so you can see that is I is getting capitalized, A is getting capitalized, S is getting capitalized, and so on. So whatever operations we are doing, these are happening uh, on the string, but the string is not getting updated. Again, I'm repeating that. And sorry. Okay, so this kind of operation can also be performed using string library. So whatever we were doing right now, till now, is the internal inbuilt functions that are there in the string data type for the string data type. However, we also seen over here that we are importing some library over here called string. So string has its own, functionality and some variables that are defined internally. So let me quickly go to the string module in Python. So if you see the string module, you will have this variables over there, sorry, and some functionalities, some functions, and the variables over here. So these are defined in this string.py file. So if you go into the details, all these libraries are actually like .py files. So there is a string.py file, there is a matplotlib.py, means matplotlib .py file, and then there is means like for whatever libraries there are in Python, there will be a .py file associated with it, and the definition of that library and whatever functions variables are there, it will be in that .py file. Okay, so let me see if I can show you this. Okay, here it is. So if you can see that this is a GitHub repository. So GitHub is an open source, platform wherein you can, put your codes and everything, which can be used by other people. So you can make your codes public, like it's a version control uh, like system in which you can, upload different versions of your code, and you can also see the versions. It is useful for people working in a team on a project, or even your own project on which you are working. So you can definitely put all your codes over here. Like if you can make it public so that others can access it, you can provide some README files in which you can, explain what your code is doing and so on. People can raise their issues and all. Like if they find some issues or bugs in your code, they can definitely point that out over here. So many of the codes that you will see in the market, that are open source, are growing better and better, uh, because people do point out all these issues. And yeah, it is a good practice to put all your code, make it open source so that others can use it, and also, you will get to know the bugs in your code when they use it. So yeah, so this is a string.py file, which is there in this CPython lib. And when you import string, you are importing actually this entire thing. And you will see that there are some variables which are defined over here. Sorry. So there's a class template here, and then there are some functions internally. Just don't be over. This is just for demonstration, not for, this is not going to come in your exam. So just wanted to show you how it looks like. So there are these variables over here, like white space. So we have used this in one of the sessions, ASCII letters, which will give you all the ABCD, means like alphabets, lowercase and uppercase. So if you use string dot ASCII, lowercase ASCII or ASCII, whatever you call it, ASCII lowercase or ASCII uppercase, that will give you this, that will return this particular strings, and ASCII letters will return the concatenation of these two strings over here. Similarly, strings dot digits will return these digits. Hex digits will give you these digits plus ABCD, lowercase and ABCD. So hexadecimal is also a type in which, is a number system. Like binary number system, you have hexadecimal number system and octal number system. Sorry. And then you have like punctuation marks that are there in Python. Not in Python in general. So you have quotation mark and then ampersand and percentage and so on, at symbol and question mark and so on. So the string dot punctuation will give you the string containing all the punctuation marks. And then you have printables, which contains all these characters, digits plus ASCII letters plus punctuation plus white spaces. So white spaces are nothing but the blank space, the tabs, new line characters, and so on. So even I'm not aware of the formats over here, but yeah, all these constitute of white spaces. And yeah, that's what. So there are these functions as well. So we'll see the scaffold in this session. And yeah, so let us go back to the Colab notebook. So we saw this particular example over here, sample string dot title. So it is converting every first digit of every word to capital letter or uppercase form. Similar kind of operation can be done with these string.cap words. Okay, so let me just use this, run this. So sample string dot lower will uh, convert everything to lowercase. Then sample string dot title will convert this first letter of every word to uppercase. And similarly, now in this case, see the difference over here. Here we are calling this title directly on the string variable, sample string. However, in this string library function, string.capwords, we saw over here, right? So in the string.py file, there is this capwords function defined, which takes string as input. So there are some other variables, means like parameters as well, but string is the input. So string.capwords, you're passing on this string over here, and it will do some functionality on it. Okay, so let me run this quickly. Okay, so I have not imported string earlier, so let me just import. So do you see this over here that these two are giving the same output? However, here we are using the inbuilt string data type function, and here we are calling using the string library function and passing this string into it. The output is the same. So is it clear so far, everyone? Sorry. Any queries so far? Okay, great. So this was all about you know using string and the difference between the string library and the inbuilt string functions. Okay, so sorry. So there are other functionalities that are there for made for string data type. For example, like we have seen lowercase, uppercase, and title case, and then there is a function called starts with. So if a given string starts with a given substring, like let's say hello over here, so it will return true. So let us run this. So there is similar function called ends with. I'll take this two and then we'll see it quickly. So this particular string starts with hello and ends with string. So this will be true. This conditions will be true over here. And if I change this, so you see that this is false because this particular string doesn't end with the string dot 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 or string three times full stop. Okay. So yeah, so this particular function will return true or false depending on if the condition is true. Okay, so this was very simple. And just for your information, I'm not sure if it is going to come in the exam, but yeah, these are very simple to remember. Like just as the name suggests, it starts with and ends with. Again, so there is a substring subworld, and you want to find the index of the starting index of this particular substring subworld. Okay, so let me just run this. So, the in string, you can again treat it as an array or a list of characters, and then the starting index of each character means like starting index over here is zero, and then this is one, two, three, four, five, six, and seven. So world starts at the index number seven, and then sample string dot find, and then the substring, whatever substring that you want to find. If it is there, uh, it will return the index of the, you know, that string. However, if it is not present, then it will by default return negative one. For example, let me just write size over here. Yeah, so this is actually returning negative one. So let me just print index here. So if the string substring is not present in the string, so this find will return negative one. Okay, so that was all about the find operation. And then, yeah, we saw this in the previous session as well. Replacing a substring with another string. So you have some substring over here and you want to replace it with something else. Again, the original content of the string is not being changed. It's just creating a copy in the memory and assigning it to a new variable. Okay, so that's pretty straightforward. So you're replacing sample with modified and then printing it over here. So let us go on to all the functions quickly and then we'll move on to NumPy library. And then we'll see two problems. And they are quite interesting. So, yeah, so let me take these two together. Let's say you have let me clear this out, a string, and if you pass it on to this list function, so as you convert one data type to another, you can also convert a string to a list. And let me just print this list. You can also assign it to a variable, but this will directly give me the output. So you can see that it has created a list of all the character in this particular string. So if you pass this string to, a list function, and then it will create a list of all the characters in the string. So we'll again see this application of this particular concept in the later part of the session. So this is just for your information. So what we are doing over here, so sample string dot split will do the same task. Let me just print this. However, it is sorry, splitting this string by default on certain delimiter, and in this case, our delimiter is uh, a white space or blank space. Okay, so sample string dot split will split this string into different words, and then you'll get a list of words. In this case, you're getting a list of characters when you're passing this string to this list function. And once you have this list of words, you can join, if you want to convert it back to the string, you can use this join function with this delimiter. Like I can have anything as delimiter over here. So let me use this. So you can see that all these words in this particular list are concatenated together with this particular delimiter over here. So here the delimiter was blank space. That's why it was looking like the original string. But you can have any delimiter, like if you want to, so I can do this over here as well. So b equal to something and dot join, and then let me pass b over here. So you can see I just converted a to a list, means string to a list of characters, and then joined every character in the list with a delimiter. Okay, so is till now, is this clear, everyone? What's happening over here?
Sir, if list of is used for sentence, whether it will take blank space?
Sorry, Leela, I didn't get that.
Sir, if list of method, if you are using for a sentence, for example, A is equal to instead of nature, if there is a sentence, how it
Yeah,
will
yeah,
be the
yeah. It
output?
will take every character actually. It will still take the character. So nature is good. So it will just take the characters.
Sir, no need the join, sir. Just a list of A.
Oh, okay. Let me just print the list of it. So it will take the list of, it will create a list of all the individual characters over here, including the blank spaces.
Okay, sir.
Yeah. So by default, it
Okay.
does that. However, if you do this a dot split, so let me print this. So for those of you who do not know, Colab or Jupyter Notebook, it by default prints whatever is the last statement written over there. However, if you want output of all this statement in a cell, so you'll have to write print. So you can see that a list of A is giving you the list of individual characters, whereas A dot split will split this into words based on some delimiter over here. Okay, so I hope this is clear to everyone. And yeah, let me move on to the next part. Yeah, so we'll try to wrap up quickly, and I'll end this session soon today after discussing NumPy and the two problems. So yeah, so you can also like remove some leading and the trailing white spaces in a given string. So this is a string with a white space, and then you have this function called strip, which will strip off all the white spaces in the string. So this is all again simple. So I'll quickly move on to the next uh, functions. So each digit is alpha. We saw each digit in the previous session, and we also saw is alpha num, al num, which will give us which will show us like if a given string is alphanumeric in nature. By alphanumeric, I mean like if it has alphabets and numbers or numbers. It can be only numbers, only alphabets, or a combination of alphabets and numbers. So that is considered as a alphanumeric string. However, if you want to see if the string contains only numbers, in that case you can use this is digit function, and then for only characters you can use this is alpha function, and for alphanumeric you can use is alnum function. Okay, and this is something new that we did not see in the previous session. So we saw in the very first session of Python, like session 2, uh, about the variable naming convention in Python. So there are certain rules which you need to follow while naming variables, and that include like starting the variable name with an alphabet or underscore, and then having you cannot start a variable name with 1 2 3 or something. You cannot have dashes or special characters in a variable name. So if a given variable name is a valid name or not, to check that you can also use, although it is a common sense, but you can use this function called isIdentifier. So you can just write a string, like if I want to have a variable with this particular name, just to check if it is a valid name or not, I can just simply, use this isIdentifier function and print it if it is a valid identifier or not. So for example, if I write at over here, so it will print nothing because identifier.isIdentifier will return false because it's not a valid string name or sorry, valid variable name. Okay. So that was about this isIdentifier function. Then if you want to count occurrences of a given, uh, string, substring in a given string, we saw this in the previous session as well. Like you can count the occurrences of a given word in a list of words. Similarly, you can count occurrences of a given substring in a string, and this will give you count of every substring over here. And then len will give you the length of the entire string. Is title will give you will return true if a given string is in title case. Uh, that is, if every character, like first character in every word in the string, is in uppercase. So if a string is not in a title case, then uh, it will return false. Then eSpace is a function that will check if a given string contains only spaces, white spaces. So we saw in this string library, sorry, uh, file, that there is a white space variable over here which contains blank slash t slash n slash r slash v and slash f. So if any of these characters are there in this particular string, then it is considered as a white space string. So sorry. So this e space will return true if a given string contains only white spaces. Then there is this empty string which doesn't contain anything. And then you can simply this is treated as a false in like if you just pass it on to a if statement. Say you pass on empty string, that will be considered as false, and then you're just using a not operation over here just to make it true. So if this is true, this string is empty, not of this will be true, and then this condition will be true over there. Okay, this is useful in the case when you can simply do like this as well. Like if you could have even written like if uh, empty string equal to this, and then do some operation over here. I can write pass as well. Okay, so this is equivalent to doing this because an empty string will be treated as false, and the not of false is true. And then If you want to extract a substring from a string, you can do splicing, in which you have the starting point and the end point. Uh, and starting point is included, is inclusive, and end point is exclusive in this splicing operation. Similarly, this is another way of reversing a string. So there are three things over here. So let me discuss this quickly. Let me take this directly. So sample string. Also, let me print the sample string. So this will give me uh, substring starting from 7. So 0, 1, 2, 3, 4, 5, 6, 7, and 7 is starting over here. While 8, 9, 10, 11, 12. Okay. So it is giving me the substring till only 11 index. The 12th is index 12 is excluded. And you can also, so there is another thing that we did not discuss earlier, which is the steps. So 7 to 12 and with a step size of 2, if you write like this, it will move ahead with step of 2. So by default, it moves with step of 1. So here you can see that 7th, it has taken 7th, and then it will take 9th, and then index 9, and then it will take index 11, and so on. Okay. So this was about this steps, and what is happening over here. You can also do like this, you know. This means that starting from 7, and if you don't specify anything, it means end. So if you don't specify end point over here, it means end of the string. If you don't specify anything over here, it means start of the string. So let me just run this. So it will take from the start till the end, but with a sorry, step size of 2. If I start from a given index, so it will start from that index and will move on with this step size of 2 till the end of the string. And if I specify some index here, like let's say, so it will just take that particular part and then it will move in with the step of 2. So what is happening over here? So there is no start and end, which means that it is taking entire string into consideration and it's moving with the step size of -1. It means that it is moving the negative direction. Okay. So let me show you this. So you can see this. It's taking from starting to end, but moving in the uh, opposite direction or the reverse direction. So it is taking this full stop G, N, I, and so on till H. So there is another way of sorting a string. There are other ways in which we can sort the string. There are inbuilt functions as well. So uh, you can use them as well. But yeah, this was something which we did not discuss earlier. Like you can use even splicing to reverse a string in Python. So is it clear so far, everyone? Okay, great. Okay, so where were we? Yeah, so yeah. Then you can check if a given character is in a string or not. We will see this application of this in one of the problems later. So if a given character is in a string or in any uh, if it is in a list, so this is the membership operator that we have seen. So if a character is in string or a list or any other data type, you'll have to specify it over here and then you can check. And this will return true if it exists in that particular data type. Okay. So this was about membership and yeah, as we saw like in this library, so there is this variable called printable in string library, which consists of digits, ASCII letters, punctuations, and white spaces. So there is this isPrintable function which is available which is inbuilt function for string data type, and it will return true if the string contains only printable characters. That is like ASCII numbers and then punctuations and so on, white spaces and so on. Okay, so this was about is printable. Then we have if a string starts with a certain prefix. So we saw that in the previous case in which uh, yeah, we had these two functions, starts with and ends with. So we can use this as well. However, we can also use splicing in this case. So sample string, I'm not mentioning starting point over here. So it is taking from starting and then till the length of prefix. Okay, so length of prefix is like just this length of this particular substring, and it is comparing it with the prefix itself. Like if this particular string, sample string contains this prefix, then print that the string starts with prefix. Okay, and then we had this remove specific characters from the string, so you can use okay. So string dot punctuation, will return you the list of all the punctuations over here. And if you want to remove certain characters over here, like char for carrying punctuation string, if char not in punctuation string dot punctuation, so it is returning the punctuation and what it will return over here. Let me just print this. Okay, before we discuss this, is this particular part clear? Like how the prefix is being checked using splicing? Okay, is it clear or not? Hello. Okay, fine. So, yeah. Okay, so punctuation string is a string over here, and then you're joining this with nothing over here, and this will create a punctuation string. Uh, Sorry, it will create a string without any punctuation characters. Okay, so let me just print this over here. So you can see that hello world. This is some text. So it has removed all the punctuation characters like exclamation mark and uh, the full stop and so on over here. Okay. So is it clear, everyone, so far? Okay, great. Okay, so let us move on to the next part. Yeah, this is something which there was some bug in the code. I think that was discussed in the previous session. Like I would have written it in this one of the cells. So just for clarification. So again, this my string dot split, I'm splitting it on commas. So this will give me a word list. However, the word list will also contains all this blank spaces as well. So let me print. So word list is over here. So you can see that there are these blank spaces in this, and I don't want these blank spaces like in the word list. So I can just simply use uh, word dot strip for word in word list. For every word in this particular list, I'm doing strip and removing this extra spaces, white spaces over here. And then that will give me a list of all the words in this. So you can have any delimiter over here. It could have been like a semicolon as well or anything. So depending on that, you'll have to specify the delimiter here in this split function. So this was all about the string library, and then we'll move on to NumPy library quickly, and then see two problems. One of them was discussed in class. So NumPy, as we discussed, is used for numerical operations in Python. So if you want to perform certain inner algebraic operations like vector operations or matrix operations, then in that case, NumPy is the base library that you can use. And yeah, to create an NumPy array, you can simply pass on a list and then uh, do this np.array function, and it will convert it to NumPy format. And then you can apply all sorts of NumPy functions on top of this NumPy array. For example, uh, np.sum. So these are the operation on the array itself. So np.sum will sum all the elements in the array. np.mean will find the mean of all the numbers in the array. np.min, minimum, will find the minimum value in this array, and np.max will give you return the maximum element in this array. Okay, so this was straightforward. Um, let's say you have like, so this was 1D array. Similarly, you can have a two-dimensional NumPy array as well. So we saw a concept of 2D list. So in this case, you have list of list, wherein each list in this list is a row in the array. So this is a matrix actually, in which first row is 1, 2, 3, second row is 4, 5, 6, third row is 7, 8, 9, and you're converting it to NumPy array and treating it as a matrix. So if you just simply treat it as a list, so you cannot, do this matrix addition and dot product and all sorts of operations that you will apply in linear algebra or matrices. So for that sake, we are converting it to NumPy array, and we'll see what all other operations that we can perform on it. Okay. And then there are these three things that once you convert a list to a NumPy array, you can print the shape of the list array, dimension of the array, and then the size of the array. So what is the difference between these three things? Shape of the array is the shape of the matrix. It can be any matrix. So in this case, it is 2D matrix. So its shape is like, so this is like 3, 3, and 3. So it is a 3 cross 3 matrix. So let me quickly show it over here. So if it were 1, 2, 3, 4, 5, 6. So the shape over here is 2 cross 3, 7, 8, 9. This is 3 cross 3. And if it were only this, it is 1 cross 3. Okay. So this shape is a tuple or tuple. It will return a tuple with the shape of each dimension. Like how many rows are there, how many columns are there, and then if it is a 3D, then how many layers are there. So and so on. It can be a 4D array as well, 5D array or 6D array. It all depends on how you are defining the array. So in general, it's a n-dimensional array. And then matrix dot ending will give you the number of dimensions. So in this case, the number of dimensions are 2. So you have like 2 cross 3, so the number of dimensions is 2. Okay. And then matrix dot size will give you the total number of elements in this. So it is 2 into 3, so there are 6 elements in this. So the matrix dot size operation, or sorry, this particular thing will give you the size of this array, particular array. So if it contains like how many elements it contains. In case of list, we had this len function, which was giving us the length of the list, which was for the 1D list. But in case you want to find out the number of elements in the n-dimensional array, you'll have to use this matrix dot or whatever variable name dot size to get the number of elements. Okay, so far is it clear? Any queries about NumPy arrays? We'll run this quickly just for the sake of visualizing what's happening. So I have this 1D array which I'm printing. Sorry. Then sum of all the element in this particular array, the mean of the element in this array, then the minimum is 1 and the maximum is 5. And then we're just printing this 2D matrix over here. And then the shape of the matrix is 3 cross 3. The number of dimensions is 2. As I said, it will return a tuple. And then the total number of elements is 9. So this is given by size. Okay. So is it clear, everyone? Okay, great. Yeah, please interrupt whenever you feel like you're not understanding anything. I'll be happy to explain it again. So these sessions are meant for you. Uh, so please utilize them as much as you can. Sorry. And okay, so this was about shape, ending, and size. Now, if you want to sum across rows and columns, so let's say this is a matrix, and if you want to sum across columns or across rows, then you can use np.sum. So np.sum we have applied to 1D array as well. So it will simply sum up all the numbers in this. However, np.sum, you will have to mention axis over here. By default, I'm not sure which one is the, okay, we'll see it right away. Okay, so what was the original array? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So 1 plus 4 plus 1 plus 4, 5 plus 7, 12. So this is like across columns. So if you want to take column sums, so in that case, you'll have to use axis as 0. If you want to sum across rows, like 1 plus 2 plus 3 is 6, 4 plus 5 plus 6 is 15, and 7 plus 8 plus 9 is 24. So in that case, you'll have to use axis as 1. Okay, but however, if you don't write this, let us see what happens. And I'm not sure. Okay, so it's simply summing up the all the elements in the array. So it is just computing the sum of all the elements in the array. So it is giving you only single value over here. So yeah. So if you want to sum across columns, you have to use axis equal to 0. Axis equal to 1 will give you the sum across rows, and just simply sum without any axis over here will give you uh, the sum of the elements in the matrix. Okay, so this was about summing across rows and columns. Then, yeah, to access a certain element, you can use this. So in the list, 2D list, we used to, access it, access array element using this two-dimensional access. Uh, so matrix is this. If I want, so it also starts from 0. So this is the zero index list, one index list, and two index list. And then if you want to access the first element, so that will be 0, 1, 2. So you can either access it like this, 0 and 0. This will return 1. Okay. And however, if you want, you can also use this in case of NumPy array. So this is also going to return you the same thing. And this is actually a faster way of accessing elements in NumPy array, because like this is going to extract the first row, and then in first row you are going to extract the first element. So to avoid that, internally just I don't know how it implements it, but this particular way of accessing elements in NumPy array is faster compared to writing like this. And it's recommended that you always use the other way, like the way like separated by commas. Again, sorry. As we saw in the case of strings, we had this starting and then colon, and so if you don't specify the end point over there, so it was like it was taking till the end. It has a different notion over here. So if you write 0, comma, colon, it means that take the zeroth row and all the columns. So this will return 1, 2, 3. Similarly, if you write all comma, let's say 1. So this will give all the rows but first column. And if you want to take second and the third column, which means index 1 and 2, so I'll have to give till 3. So I want index 1 and index 2, but all the rows. So in that case, you can do this. And if you want to splice certain part of it, like say row 1, 2, and then column, row 0, 1, index 0, 1, 1 in rows and 1 and 2 in column. So you can do like this as well. So 0 to 2 will go from 0 to 1, and then this will go from 1 to 2. So you can extract a certain part of the array as well. Okay. So is this way of splicing clear, everyone? Okay. Yeah, please let me know if it is not clear. So in this first place, you are so mentioning the rows, and in the second uh, place, you are mentioning the columns. So you can mention the range of the rows you want and the range of the columns. If you don't specify anything over here, means like if you just do all comma all, so it is going to give you apologies for the background noise. So there is a so this is going to give you the entire array. However, you can splice certain rows and using the splice operation. Okay. So yeah, I hope this is clear to everyone. We'll move on to the next part. So this was column sum, row sum, and then splicing, indexing, and splicing in case of uh, metrics. So similarly over here, if you don't specify anything, it assumes like you are starting from 0. And then if you don't specify anything over here, it means that after the colon, it means that it will go to the end of the particular dimension, like if it is a row or a column dimension. Then in case you have two arrays, number arrays, you can do sum of arrays, subtraction of arrays, multiplication of arrays. It will do the element-wise operation. So it will um, do 1 minus 4, 2 minus 5, 3 minus 6, and so on. Like 1 into 4, 2 into 5, and 3 into 6. And then there are some inbuilt mathematical operations as well that can be applied uh, on these arrays. So np.sqrt will find out the square root of each element in this particular numpy array. Okay. And then similarly, there are matrix operations that can be performed. So you have a matrix A, matrix B. So you can take a dot product of two matrices using NumPy. And dot product is nothing, we saw it in the previous session. So I won't go into the details of that. And then matrix A dot transpose dot T will give you the return the transpose of the matrix. So if it is 1, 2, 3, 4, so it will return like 1, 3, 2, 4. Okay. Yeah, so this was all about the matrix operations, then generating arrays with specific patterns. Uh, so yeah, so let me just quickly discuss this. So np dot zeros and the dimension over here. So we are passing a tuple over here, 2 comma 3. This means 2 rows and 3 columns. So it will create an array, empty array, numpy array, with all zeros and dimension 2 and 2 cross 3. Similarly, np.ones will create uh, a numpy array with all ones in it with a given dimension over here. And np.identity will create an identity matrix of dimension 4, which means that it will create a matrix of 4 cross 4 in which all the diagonal elements are 1. Okay. So identity matrix is a special type of matrix in linear algebra in which all the diagonal elements are 1. And if you specify here any dimension, like let's say 5, so it will create a 5 cross 5 matrix and with all the diagonal elements being 1. Okay, so that was about generating specific matrix type. And then you can also create random matrices with random numbers. So here it was zeros and ones and then this identity matrix. You can also create random matrices like np.random.rand 3 cross 3 will give you a random matrix and uh, you can, okay, let me just run this. So it is creating some random numbers in a 3 cross 3 matrix. Okay. And then once you have an numpy array, you can do a reshaping of the array as well. So if you have an numpy array, which is 1D over here, so flat array dot reshape will 2 comma 3 will reshape this particular array with 2 rows and 3 columns. But you'll have to be very careful over here that this 2 into 3 should be equal to the number of elements in this array. Okay. So let me just print this out. So the flat array is the single array, 1D array, and this flat array dot reshape will reshape this particular array in to whatever dimension you have mentioned. However, if you don't want to mention the other dimension, like you just want the number of rows, but whatever, so it should take care of like the number of columns based on the number of, elements in it. You can just simply specify -1 over there. So it will, by default take it as 3. So if I just do 3 here, so you can see that it is taking the other dimension by default based on the number of elements in it. Similarly, I can specify -1 over here and then 3 here, but at least you should mention the other dimension. So yeah, it's doing the same job as we did earlier. Okay. And if you have like, a multidimensional array, so reshaped array, and if you just do reshape and pass on -1 over here, so it will flatten the array. Okay. So if it is a multidimensional array, and if you pass on this -1, so it will just flatten out that array and so on. So I hope this particular part is clear to everyone. You can use this. You can try writing means playing around with this code and then explore it in detail. So there are many other things that you can do with reshape. So I'm not going into the details now of this function, but yeah, please do look into it. Okay. So this was all about it, and then I'll quickly discuss image compression over here. So there are two ways in which there are multiple ways in which you can do image compression. So sorry, let me just print this image. So image is nothing but matrix, a 2D matrix with certain number of rows and certain number of columns, and each cell in that is having uh, RGB value or pixel value. Okay. In case of colored images, you have the red, green, and blue. So the value of the red, the value of the blue, and the value of the green. Okay. So it's a 3D matrix actually, in which each layer is corresponding to each color, RGB. And the combination of these three colors will give you the final color. So in this case, I have this image of a puppy. It's a grayscale image, and this bird is uh, you know, a colored image. So one way I can, uh, so there are this like function in Python, sorry, in which like, so I'm using this pillow library to read this particular image, and then I'm saving it with certain compression quality. Okay. So if you want to compress to a certain level, like higher the value, higher will be the compression uh, of the image. So I'm passing this image, like calling this image dot save with this compression quality parameter being passed over here, assigned to this quality parameter. Okay. So this will kind of like save this. So you can see this. So this is like a compressed image over here, and then this is the original image. Again, apologies for the background noise. Uh, so yeah, this is the original image and this is the compressed image. So you can see that it has got some a bit blurred. And then what we are doing over here is like we are just trying to see the difference in the size of the original image and the compressed image. And you can see that over here, like the earlier image was like 13601 bytes, and then the compressed image is reduced size. Okay. And compression ratio is nothing but like the original, like the compressed original size divided by the compressed images size. So this was one way in which you can directly compress an image by passing on this compression quality into this image.save or like image object.save. And there are other ways as well. So grayscale compression, as I said, uh, color image is nothing but a 3D matrix. Uh, so if you want to compress it, you can simply convert it to a grayscale. So grayscale is nothing but only one single matrix. However, color image is having three layers, like one for red, one for green, and one for blue. So if you just convert it to grayscale, it will just become one layer one. And then that is kind of like reducing the size of the image by three folds. Okay. Uh, so you can see over here, I have this grayscale image, and then I have this actual image over here. Okay, so that was the grayscale compression. You can do a thumbnail compression as well. Like you can convert the uh, image to a given pixel size. Like in this case, I'm just converting it to 100 pixel cross 100 pixel. And let me just run this quickly. So, so I've just reduced the size of this image to a shorter dimension, like 100 cross 100. So that is also going to compress the image, but there will definitely be some information loss the moment you do compression, unless there is redundancy in the data. What I mean by redundancy is that there are certain, so if there is like, for example, there is something called as Morse code. Okay. So what they do is, in this case, they assign, so whatever is the most frequent character in this English language or whatever language, that character will be assigned the smallest string. So for example, E is assigned dot, T is assigned dash. So these are the most frequent characters in English. Then after that, you have A, I, S, and H, and all so on. So depending on the frequency, so most frequent character is given the shortest string, and then least frequent is given the longest string. So you can see that uh, I can, so instead of assigning like four different equal length string to everything, you can assign shorter to most frequent and longer to. So this is kind of like going to save you some space. Okay. So in this case, you can compress. So if there is redundancy in the data, you can compress it and then pass on the information without any loss of information. So, however, in certain cases, it's difficult. Like if everything were equally probable in English, so in that case, it would have been difficult, to assign this. Uh, Strings to each of the characters. So it is based on the frequency of these characters. So if every character were equally occurring, like uniformly distributed, so in that case it would have been difficult. So there is no compression that you can do. So similarly in case of image as well, like if there is any redundancy, which is hardly there. In that case, you can compress it without losing much information. But in most of the cases, you get a pretty good quality one, even after compression. And yeah, then image rescaling is like you can just simply resize the image to some height and width. So this is a resized one, but you can see that it is kind of like a stretched image, not the one like actual image. So that is also one way you can just simply resize the image to some different dimension. That is also a way of compressing the image. So here we are just printing the original size and the compressed images size. Okay. So this was all about image compression that just wanted to touch upon. And there is interesting problem called Josephus problem. So how many of you know about this Josephus problem? Just want to know. Sorry. Uh, I see. So Josephus problem, I see. Okay. So yeah, we'll discuss it in detail. So let's say, let me just open draw online. Okay. Are you able to see this screen in which there is this blank screen? There is this white screen. Are you all able to see this white screen? And I'm writing something over here. Okay, great. Okay, let me just select this. So Josephus problem is actually a problem in which, so there is a story that there were like some 41 Jews soldiers, and they were like surrounded by Roman army, and they didn't want to surrender. So what they thought was like they thought like they will kill each other, and instead of surrendering, and then so how they were trying to kill each other. So the first person will kill the next one, and similarly, like so on. They'll keep on killing the person till the time the last person remains, and the last one was supposed to, you know, uh, suicide. So that's not a very good example that we are discussing in this session, but yeah, so Josephus was one of the persons in this list of 41 people, soldiers who didn't want to, die. Like he was okay with surrendering to the Roman army. So the task was to, find out a position such that towards the end, only Josephus will be left alive. Okay. So in this particular problem, so there is a pattern actually. Like, let us see. So if there is only one person, that is like Josephus. So that's the winner. If there are two people, so this is one and then this is two. So first we'll kill two and then that is the winner. Okay. So, so when there is one person, the winner is one. When there is there are two people, winner is one. Now, what if there are three people? One, two, three. So one kills two and then three kills one. So the left out is three. So when there are three people, the winner is three. And then when there are four people, so we're just trying to find out a pattern in this. So one, two, three, and four. So one will kill two and three will kill four. Then we are left with one, so one will kill three. So when there are four people, the winner is one. Now what if there are five people? One. Okay, so let me just just write one, two, three, four. One. 2, 3, 4, 5. While we are discussing, we'll see the intuition. So this is a computational problem actually. So we can write a function for this. So 1 will kill 2, 3 will kill 4, 5 will kill 1, and then 3 will kill 5. So when there are 5 people, the winner is 3, and so on. So there will be a certain pattern over here. Okay. So what's happening? So if you observe, we don't have time, but okay, let me just quickly go on till 8 and then we'll stop over there. So let's say you have 1, 2, 3, 4, 5, 6. So 1 will kill 2, 3 will kill 4, 5 will kill 6, and then 1 will kill 3, and then 5 will kill 1. So when there are 6 people, winner is 5. When there are 7, let's say. So 1 will kill 2. Let me use different color now. 1 will kill 2, 3 will kill 4, 5 will kill 6, 7 will kill 1, then 3 will kill 5, and then 7 will kill 3. So then when there are 7 people, winner is 7. And then when there are 8 people, let me write 8 over here and then use another color here. So 1 will kill 2, 3 will kill 4, 5 will kill 6, 7 will kill 8, and then who is left? 1 will kill 3, 5 will kill 7, and then 1 will kill 5. So the winner is 1 again. So if you see that when there are power of 2 number of people, the winner is always the first person. Okay, for 2, 4, 8, and 16, and 32, and so on. So, so whenever there is a power of 2 people left, in that case, the first person who is starting in that round will be uh, alive. So whatever number you have, so the intuition over here is that, let me clear this out. So intuition over here is that, uh, let's say 7. So 7 can be written as a summation of power of 2's. Okay. Okay. Let me just make this circle over here. 1, 2, 3, 4, 5, 6, and 7. So the moment 1 kills 2, so right now there are 7 people, right? Now 1 kills 2, so there are 6 people left. 3 kills 4, 5 people left, and 5 kills 6. Okay, now 4 people left. Now this is the starting person now. Once you have the even number of you know people left and the one who is starting, that person will be alive. Because as we saw, like whosoever is starting in the even number of people, that person will be alive. So what is the intuition over here? So whatever, so 7 can be represented as the largest power of 2 that is there, which is 4 over here, plus 3. So here every alternate person is, killing. So 1 is killing 2, 3 is killing 4, and 5 is killing 3. So there should be 3 killings, and then the remaining person will be the first person in the remaining set of people, even number of peoples. Okay. So any number n, sorry, can be written as nearest power of 2 plus some L. So in this case, it was 4 plus 3. So in that case, the person who will remain alive, like assuming the index starting index is I think 1, will be always 12 plus 1. You get the intuition over here? So in this case, it was 7 was 2 to the power 2 plus 3, and then you kill 3 persons, and then there are only 4 people left. So once you have the 2 to the power people remaining in the list, then whosoever is starting first will be the winner. So that's what is happening over here. So it is 2 to the power a plus l, and then each person is killing 1 person. So it is like uh, this L number of killings should happen, and for that you are passing on to 12 people, and then plus one is the person remaining over there. Okay, so that's the intuition. So it will work for any case. So is this intuition clear in the Josephus problem? What's happening over here? Sorry. Okay, great. So yeah, so how you can do this? So in the very beginning of the course, not very beginning, but in when we are discussing the operators, we also discuss these bitwise operators. So let me just quickly show you. So when the number is, let's say, 17, what is the uh, highest power of 2 that is there? 16 and followed by 1. Okay, so the person who will remain alive will be 2 into this particular 1 plus 1, which is 3. Okay, let me take some bigger number. Mm, let's say 63. So the highest power of 2 over here is 32. Highest power of 2 less than this number, followed by, so if you write it in terms of 2 to the power, so 2 to the power 5 plus 2 to the power 4 plus 2 to the power 3, sorry, yeah, just trying to find out the binary representation of 63. Okay, let me just quickly, let me just take a smaller number only. So it was 16 plus 1. So 16 is 2 power 4, then 2 power 3 is 0, 2 power 2 is again 0 over here. So like this is 1, 0, 0. 2 power 1 is 1, and 2 power 0 is, sorry, 2 power 1 is 0, and 2 power 1 0 is 1. So what I'm doing over here? So 2 power 0 is 1 plus 2 power 4. So the binary representation of 17 is 10001. Okay. So the answer is 2 times this particular number plus 1. So what we saw, like, does anyone remember what we saw? If you want to uh, multiply a given number by 2, so let's say any number L, so what kind of operator, bitwise operator can be performed, operation can be performed on the number? Anyone? Like we saw some bitwise operations. Okay, this might not have been covered in your lectures, but just this is just for your information. Okay, let me give you a hint. So there was this left shift and right shift operation. So which one will multiply a given number by 2? If you left shift or right shift. Left shift is nothing but like shifting these bits by 2, like one place. So whatever number you have, let's say 17, and if you left shift it by 1, so it is going to like shift every bit one by one, and then the last bit will fall off. Okay. Similarly, right shift is like this rightmost bit will fall off, and then everything will move towards the you know right side. So if I want to, so this is the highest power of 2, which is there in 70, and this is the remaining number. Okay. So if I want to multiply this by 2, I can simply just left shift this. So it will become 0, 0, 0, 1, and I can just add 1 over here. So this is equivalent to doing a left shift once and then adding 1 to it. Okay. So multiplication of 2, multiplication by 2 is equivalent to left shifting this bit, doing this bitwise operation of left shifting by 1 and then adding 1 to it. Okay. This is nothing but just rotating this one and then putting it over here. Is it clear, everyone? What's happening? Okay. Okay. I think somebody just left, just joined. So what we are discussing is that the solution to the problem will be 12 plus 1. And whatever is, so we just represented this number as a um, binary number in which you have the highest power of 2. Okay. And then you want to, whatever is the remainder, you want to take twice of it and add 1 to it. So to take twice of a given number, you can just simply do a left shift and then add 1 to it. Okay, so this is equivalent to applying this bitwise operator of left shift by 1 and then adding 1 to it. So that is what is happening in this function over here. So I have written this Josephus problem. Uh, K equal to 2 means like every alternate person is being killed. Okay, it can be any k value, like if one person can kill the third person and so on. So k equal to 2 is the problem in which is defined as a Josephus problem. In general, k can be anything, and we are discussing only k equal to 2 in this session. So this solution is applicable for k equal to 2 case. So we are first of all we are passing on the number n dot bit length will give you the total number of bits in that particular in the binary representation of that number. For example, over here, in case of binary representation of 17, how many bits are there? 10001. So this is like 5. So 17 dot bit length will give me the number of bits in the binary representation of 17. And I'm shifting this one by n bit length minus 1. So actually what's happening over here? So let's say 1 is like this. So in the binary representation, 2 power 0. Okay. And the highest power of 2 in this case over here was 16. Okay. And the length over here, so bit length was 5. And 5 minus 1 is 4. So if you're shifting this 1 by 4, sorry. Oops. The bit length was 5 over here, and you want to if you shift this 1 by 4, so you are getting the highest power of 2 in this less than this number. So that's what is happening over here. So you're taking this 1 and doing the left shift by n bit length minus 1. So you'll get the highest power of 2. And what will be the L value? L is nothing but n minus the highest power of 2. So over here, n is nothing but 17 minus 16, which is the highest power of 2 less than 17. So whatever L value is left, you can simply do 2 into L plus 1, which is equivalent to doing the left shift of L by 1 plus 1. You could have simply written this 2 into L plus 1. But I just wanted to, show an application of bitwise operation because we discussed it in the class and then we never, had any application of it. So yeah, this was one occasion I thought like I'll just discuss this and show you the application of bitwise operation. So this is used in many coding challenges because bitwise operation is sometimes faster than normal multiplication in many scenario. So like if you want to multiply something by a power of 2, so you'll have to do certain number of shifts accordingly, or divide by power of 2, so you'll have to do right shifts and so on. So yeah, this was all about the Josephus problem being solved using bitwise operator. And yeah, as I said, like if you pass on 1 over here, the or any power of 2, the remainder will always be 0. And 2 into 0 plus 1 is always 1. Okay, so survivor position is always 1. However, if it is non-power of 2, then in that case, the survivor position depends on the remainder. Okay, that is nothing but the number minus the highest power of 2 less than that number. Is it clear to everyone? Yeah, even if it is not, please go back and check this video out. And yeah, I am sure you'll be clear with this. So try to understand it. Okay, yeah,
Actually, I
Lila.
thought of asking why we need to go for that binary and shifting concept. Instead, we can keep that integer, but you said that will be fast.
Yeah, yeah. So in case, so we'll not go into the details of it, but internally these bit shifting bitwise operations are actually faster than multiplication. So it comes under a course called operating system, no, sorry, computer organization and architecture. So in that, if you go into the details, it will be like a complete course over here. So the way the multiplication happens is pretty, complicated, and this shifting by 1 bit or like this bitwise operations are actually pretty faster than those multiplication operations. So yeah, that's why we are using this bitwise operator over here. But yeah, definitely you can write it simply like as I said, you can simply write like 2 into L plus 1. And to find the highest power of 2 also, you can use some other method as well. So that's all up to you. But this was just an application of bitwise operator I wanted to show in case of Josephus. And also Josephus problem is again so this particular flames problem was discussed in your class. So what was this problem? So you have been given two names. So let me show this. So the task is over here. Like you have been given two names. The first thing is that you strike out all the common ones, common characters in the two names. Now you are left with certain characters in the first name and certain number of characters in the second name. So there are three characters plus four characters in this. So there are in total seven characters left. Now, what the person does is, so you have these flames. So every seventh element is being struck, like starting from one. So one, two, three, four. So one, two, three, four, five, six, seven. So first F is cut, then L equal to So starting from here, 1, 2, 3, 4, 5, 6, 7. A is cut, and then starting from M, 1, 2, 3, 4, 5, 6, 7, and E is cut, and so on. So whatever is left is the relationship between these two people. That's what is this the end goal of this particular game. It's just a game, but why I discussed Josephus problem before is that this particular flames is again based on this Josephus problem. In case of Josephus problem, the K value was 2. In that case, like you were just killing the next element, close to a given element, which was alive. However, in the case of flames, you are killing this now. So let's say these are people. So first person is killing the seventh person. In this case, it ended up killing itself. So and that seven or the count that you are getting is from this remaining characters over here in the strings. So that is the motivation. That was the motivation behind discussing the Josephus problem first, and then we'll go on to discussing flames. We'll quickly discuss the code for it. It's pretty simple. So what you are doing over here? So we discuss strings for the same reason. So you have name. So yeah, I'm writing this function called flames game, passing on two strings over here, converting it to lowercase, as we saw earlier that if you want to compare two strings, like if they have like different cases mentioned over there, so that won't be like compared. For example, uh, the two strings Saish and Saish, these are actually the same names, but the case of this particular character is different. That's why it won't be compared one to one. Okay, so to compare them and then strike out the common characters, sorry, we are first converting it to lowercase and then removing all the blank spaces. So for example, like in certain cases, the name might be like, for example, if I write the full name over here, Saish Jaiswal over here, so there is a blank space as well. Like if I want to consider this entire name of mine and then, like remove the blank space. So for that, you're just using this string lower, and then on top of it replace the blank spaces with nothing. So this will return this kind of a string uh, with everything in lowercase. So you are converting everything to lower. Then we saw the application of list as well. So once you pass on the string to the list, it will create a list of characters. Okay, so now you have a list of characters in first string, list of characters in second for second. Now you are moving on to the characters in all the characters in the first name and seeing that if that character is in the second name as well. If that is the case, you are removing that character from the first list as well as the second list. Okay. Why we converted it to list in the first place? Because strings are not mutable, so you cannot like strike out the character in the string. So we converted it to list just to remove these elements in the list. Now, after doing these operations, we will be so as discussed over here. So it will create a list of five characters P R I by A, and it will create in this case there will be a list of six characters R A J E S H, and after removing all those common characters, you'll be left out with P I Y in first list and J E S H in second list. Okay, and now what you're doing, you're just computing the count. Length of first list and length of second list. We give you the total number of remaining characters. Now, if the count is 0, it means that both the names are same, Saish and Saish. However, if it is not, then you keep on, you know, cutting the count starting from an element. You keep on eliminating the count. So if count is n, so you keep on eliminating the nth element in that. So count modulo length of flames is 7. Uh, what it is doing over here is like count is, let's say, 7. So 7 modulo 7. So the length of flame is 6 over here. So 7 modulo 6 will give you 1, and 1 minus 1 will give you 0. Okay, so this will give you the index of that element. So you'll have to go in round. So this is like a circular list that you are considering. That's why we are using modulo over here, so that once you reach the end, then you can go back and then go on to the initial characters as well, again. So you are trying to find out the index at which, so let's say you stop at L. So you want to remove this L from the list. So you will splice the list before L and after L and concatenate them. Okay. So right of L, left of L, and then concatenate the two lists. So this is the basic logic that I'm discussing. You can go into the details of this later. Till the time the length of this flames is 1. Till the time the last character is left. Now whatever character is left, so you're just creating a dictionary over here. F stands for friends, L for lovers, and so on. And then out of the dictionary, whatever character is left, I'm taking the corresponding relation and then returning that. Okay. So this was all about the application of, different concepts that we saw in today's class. So we saw lower, we saw replace, then we saw creating a list of characters from a string. Then these are like the uh, like going over, you know, the characters, and then we are seeing the membership over here. Then we have this remove function, then length of a string, concatenation, and it's not concatenation, like summation of the two lengths, and then uh, the concept of while loop that we have discussed already. Here we are discussing the splicing, and then the concept of dictionaries coming into picture over here. And yeah, that's it. So a lot of concepts covered in this one single problem or program. So is it clear? Even if it's not, like, please take your time. I don't want to rush on this. You can go back and look into this code and then see what is happening step by step. There is something in Python which I have not discussed. It is called as debugger. So it's there in C as well. So there is a library called PDB, Python debugger. So if you want to stop at a certain point in your code, like if you want to run a code and then debug it, like if you want to see like what will be the output till that particular point, you can read it in detail. So you can use this pdb.setRes. So once you run this code, let me just try running this. So I'll just write A, B, C, D, first name, E, D, C, J is the second name. Okay. So it has stopped at this particular point after this pdb.setRes. So it has not run this particular function. So it is still over here. So you can see that what is the content of name over here. So I can just print out name one, name two, and then verify like if there is any issue over here, like if it is working fine. The code before it, like whatever variables you have before it are working fine or not. So you can do that debugging. And then if you can just quit it. You can either just do continue. For continuing, you can just have C over here. If you write C, so you just continue the code. So it will run and then you know give you the output. Else you can quit the code and remove this debugger. In this case, I'll just comment this out and run this code again. So some random string and again some random string with, okay. So it has simply run over here. So yeah, that was all about it. So PDB is something which you can use to debug your long codes. It's Python debugger. You can read up a bit on that as well in the documentation. So let me quickly go on to the questions. Oops, I've already answered this. So which module in Python provides constants and functions for working with strings, which is clear strings? What does string.ascii contain? Yeah, please try answering it quickly. Okay. So we saw it in the string library. ASCII lowercase will have will contain the string of all the lowercase alphabets. ASCII uppercase will contain the string of all the uppercase alphabets, and ASCII latest will contain both uppercase, lowercase, and uppercase. Okay. Oops. Yeah. So the answer is both uppercase and lowercase letters. Which function from the string module capitalizes the first letter of each word in a string? Yeah, you'll have to be very careful over here in this case. It is asking the string module, okay, not the string data type. So in string data type, there is this title function. However, in string module, there is a function called cap words. So module is nothing but library. So you'll have to be very careful about the wording of the question. Okay, so in this case, we saw this, right? Where is cap word? Yeah. So sample string dot title. So this was the string data type function. However, the string module is having this function called uh, cap words. So yeah, module means library in this case. So how can you check if a string contains only lowercase letters using the string module? Deepika, is it clear? Okay, great. Yeah. So whenever this term module comes, you'll have to be very specific, clear that it is referring to a library. Okay. So answer is lower. Uh, which of the following is used for generating random passwords with the string module? So random library is something which we saw earlier, and the answer here would be you can just guess. Out of all this, we have discussed only one thing, which is actually the answer over here. So the correct answer is in view of time, I'm just rushing. So random dot choice will just choose some random, characters from a given set of characters in a string. So ask string dot ASCII letters, as we discussed, will give you the set of all the lowercase, uppercase alphabets, and from that you are just choosing some random, alphabets. So that will generate a random password. What is the purpose of string dot punctuation constant? Again, we saw the application. I'll rush on. So the correct answer is it contains punctuation characters because we wanted to remove the punctuation characters from a given string. So we were getting the list of all the punctuation characters, and using the membership operation, like we were able to find out like which particular character is a punctuation character, and they were removing that and then uh, like ignoring that and then using only the remaining characters in the string. So which function is used for formatting strings with placeholders in the string module? Okay, this is something I think we have not discussed. String dot template and string dot substitute. Um, okay, let me just quickly go on to let me see if it is there. Yeah. So there are some functions in the Python string module. So we have discussed one, string dot cap words, which will convert the every first character in every word to capital, corresponding capital one. So there is this formatter function which will so what we are doing over here, we are just creating an alias for this function formatter, an object of this formatter function, and then we are calling with this we are uh, so fmt.format, you pass a string with a brace over here, and then whatever string you want to replace this brace with. Okay, so that is the formatter. There is a simple way of doing this as well, so we saw that as well. So you can just write print f and the string, comma, whatever string you want to replace the particular brace with. So that can also be done. This is just for your information. So formatter is something which you can use to replace a brace. And then there is this template over here, similar to formatter, but in this case you are giving a variable name over here with a dollar, and you can substitute that particular name, uh, this entire dollar name with a string. So that is like a template function in string class, sorry, string library. And yeah, that was all about templates and the formatter. And there are some functions in the like if it is a is digit and custom format, like let us not go into the details of this. Like it's not very relevant to you yeah, right now. But yeah, there are the functions in which in string library which you can utilize. So here, the correct answer over here is string.template, because you can replace a placeholder in the string module like uh, using a string.template. This may not be covered in the class as well, so don't bother about it. But yeah, this was just for your information. So what is the so in view of time, I'll let you solve the rest of the questions. So this is the last question we'll see now. So we are importing string and s equal to hello world, s dot strip string dot punctuation. So you are taking string dot punctuation as the uh, strip element over here. And what will be the output? Okay, I have already discussed it. So what's happening over here is like you are removing all the punctuations in the string. So string dot punctuation will give you the list of all the punctuation, a string of all the punctuations. And if it is occurring in this particular string, it will just remove that particular one. Okay, so if you don't mention anything, it will by default take white spaces. And if you are mentioning something over here, it will remove all those characters. So it is not removing the white spaces now. It is removing only the punctuation. So you can see that the comma over here is removed. So that's what is happening over here. So I'll let you go over another other question. So this was the last question. Okay. So which math problem Flames is related to? So the answer is Josephus problem that we have already discussed. So yeah, that was all about today's session. If there are any queries, please feel free to ask in the next session. Next session again might be preponed or postponed. I'll let you know through the NPTEL team. So please keep checking your emails. So just in case, like if there is any change in the schedule. So yeah, thank you so much everyone for joining, and I hope the session was useful. Yeah. Please let me know like if you want me to discuss any specific concept in the next class. I'll just try to prepare uh, some questions on that. So yeah, thank you. Thank you for joining and have a nice day. Uh, I'll end the session now. Thank you.